Hey, welcome back. In this video, we're going to introduce Ansible. With Ansible, you can create infrastructure as code that automates the provisioning and all the updates and management of your environments, including your development, maybe your staging, and your production environments. So let's take a look at Ansible today. So in this video, we're going to introduce Ansible. We're talk about its background, what it is. We're going to cover some terminology, and then we're going to hit some examples. In these examples, we'll cover a lot of the fundamental concepts so that you can springboard from them into your more complex configuration. Okay, so all the code that we're going to go through today, I put up in a GitHub repository. That GitHub repository is under my name, and then vids-ansible-intro. Not only is the code here, but all the concepts that we're going to cover at a high level at least are in the README document. Later on, if you have some thoughts and you have some different questions, you may be able to find it right here in the README. So first thing I want to do is I want to open up the Ansible homepage and just show you what's there. There's not much here on the Ansible homepage. So this is a product of Red Hat. So Red Hat maintains and publishes this platform for us to use. And there's a lot of different links here that you can find, especially here at the top on the documentation. And we're just going to handpick some of these. I have some of them saved over here in this GitHub repo. So first of all, I want to cover terminology. You can open up this terminology page and you can see all these details here. And here you can see a visual representation of what Ansible is. So we have these nodes that we want to manage. And we have this control node that has Ansible and some other things we'll talk about install on them. And then from the control node, we can execute tasks that change the manage nodes. And so if you really look at what Ansible is, here's some bullet points. Ansible runs on a control node. We talked about that. Remote systems are managed nodes, and you can have multiple remote systems. Managed nodes form what's called an inventory. And so there's going to be an inventory file, and we'll look at that in a little bit. Managed nodes in the inventory can be organized into groups. So I may have a couple of servers as like a database, and maybe I have a couple of different servers which are my web application. So all of these nodes can be grouped into kind of categories, and then we can push updates that target those specific categories. Ansible runs tasks, so there's this concept of a task on different groups. And again, so we may have tasks that are targeted for our database or our web application. Tasks can be organized into plays. We know as sysadmins, sometimes when we're installing things, there's a number of different steps I have to go through in order to fully install a package, for example, MySQL or Nginx. And so every one of those steps is translated into a task. And so we might create a play which has all the tasks associated with installing Nginx, for example. In the next level of hierarchy, I have tasks which are organized into plays. Plays can then be organized into playbooks. So I may have a playbook, for example, that deploys my whole application. That would have tasks associated with maybe deploying Nginx, configuring Nginx, deploying PHP FPM, configuring PHP FPM, deploying my web application itself, configuring Nginx comp files so that my application is served up. So all of those tasks can be rolled up into one playbook. And as we just talked about, these playbooks can then orchestrate kind of these larger changes. A very important concept for Ansible is idempotent. What this means is if I have a playbook and the first time I run it, it makes changes. If I run it again right away and nothing's changed on that host, then the Ansible will not make any additional changes. So the first time I run it, it'll make the changes. After that, I can run it as many times as I want, and there will be no more changes made to that host. So that's important because I want to have infrastructure as code in place. So I can have this code, I can run that code whenever I want to provision a web server. If I'm unsure of the state of the web server, I can run that code again, and it will not make any changes besides getting it back into whatever state that I wanted it. Ansible is a Python package, so you install it using pip. So when you run a playbook, what Ansible does under the hood is it puts together what Red Hat calls a module. And this is probably because Python has this concept of modules also. So what this Ansible module does is it contains all of the information of the desired state for that node. And then Ansible uses SSH to remotely execute that module to bring that node up into the desired state. And as it's trying to bring that node into the desired state, it's gathering information. So if a step succeeds, it'll say okay. If a step fails, it'll tell you that it failed. And so when it's all done, I will get back information about the status of that node. And finally, Ansible just cleans up after itself after it's done. So before it closes out the SSH, it deletes anything that it brought over with it to run that module. Finally, let's talk about the requirements that you need to run Ansible on your control node and your managed nodes. To me, this is probably one of the top reasons why Ansible stands out in the class of configuration management tools like Ansible and Puppet, Chef, F. The Ansible requirements for your managed nodes are pretty minimal. You just need to have Python installed and you need an SSH account. A lot of Linux environments already have those by default. When we're working with Linux, Ubuntu boxes and things like that, those things are already set up. We don't have to do anything with our managed nodes. Our control node, we have to have Python, and then we have to have the Ansible Python package installed. And one of the things I will show you is that instead of having Ansible directly installed on your control node, like your MacBook or wherever you're developing on, you can run Ansible using a Docker package, and we'll get to that in a little bit. Okay, so let's take a look at a few examples here. And just for clarity, what I'm going to do is I'm going to drag this off to the side, but I'm going to copy and paste a lot of commands. That way you don't have to sit here and watch me type. I'll just copy and I'll paste them in and let them run. But while this is still here, I do want to point out this important message right here at the very top. The IP addresses in the inventory files are IP addresses for my current situation. So these are EC2 instances that I have spun up currently in Amazon. I'm going to spin them down later on, so I don't really care about the IP addresses. But you, if you were going to try to download this code and get this to work, you would want to update these inventory files so they represent your state. Just a little bit here, I'm using JetBrains' PyCharm here. On the very top, you see the code, and then on the very bottom, you're going to see the terminal window. And I'll do my best to zoom the window and let you see kind of clear what we're doing. So the very first command I'm going to copy and paste is Ansible -- version. And what that's going to do is just document what version I'm running on. So if later on you have some issues with this code, maybe it's 3 or 4 years down the road, maybe Ansible has changed. This is one of the things that I will say is there are a lot of examples of how to do certain things on Ansible. And generally that's a huge benefit. So if I want to learn how to do something with Ansible, like I want to learn how to install Nginx, I can do a search on Ansible and Nginx, and I'll get a lot of examples. You will find that examples from maybe 3 or 4 years ago using different versions of Ansible or different versions of PHP, they won't work. But at least they're going to point you in the right direction. Lots of information out there. You may have to kind of sift through kind of stuff that really works though. I'm currently running 2.17.2. You can see my Python version here is 3.12, and these are some other libraries we'll talk about. Jinja is a templating framework used by Ansible. I'm running 3.1.4. All right, the next thing I'm going to do is I want to just review this inventory.ini file. So previously we talked about how managed nodes can be grouped in our inventory. And this is an example of our inventory.ini file. And here you can see a number of different nodes. So what you see in square brackets, that is kind of the group name. This group name is called Jumpbox, and here's an IP address. And by the way, all of these IP addresses, these are all EC2 instances that I've spun up in Amazon for the purpose of this video. But if you want these examples to work on your environment, then you're going to want to sub in at least 4 different IP addresses for computers that you have access. So I have one Jumpbox. So I have one instance in a group called Swarm Manager, and I have 2 instances in a group called Swarm Worker. Now, as you can imagine, these are Docker Swarm instances. It's a Docker Swarm environment. I have a previous video setting that up, but for now, that's what those instances are. And then the next section, on lines 11 through 13, you can see how there's a group formed by adding 2 other groups together. So this is a group called Swarm, and it's based upon some children. So you can see there's Swarm Manager and Swarm Worker. Later on, I'm going to be able to refer to all of these instances by that group name called Swarm. I also have a group called All, which includes the Jumpbox and all the Swarm nodes. So you can see how you can use these children, this :children concept to build different groups together. All right, so one of the first commands we're going to run is this. So Ansible -inventory -i, and I provided the inventory.ini file, which you can see here, and this -- list. And when I enter, it's going to give me essentially all of this information back in a different format. This is a JSON file. So what I can see when I run that file is I get back a JSON response. And there's a couple of nodes. _meta has this host vars. We're going to talk about host vars in a little bit. But then I start to get back all the different groups. So All, which is a group that I built here at the very bottom, and it's built on Jumpbox and Swarm. And you can see the children are Jumpbox and Swarm. And it also includes anything that's ungrouped apparently, but I don't have anything that's ungrouped. So Jumpbox is another named group. And then the host in this group, I just have that single node, that 34, 227, 194, 94. So I have this node called Swarm. Again, it was built from children, and it's built from the manager and the worker nodes. And then I have Swarm Manager, and you can see the single host there, and I have Swarm Worker, and you can see the 2 hosts. That is in the inventory command. All right, so up next, I want to take a look at an ad hoc command that we can run from the command line. So first of all, we're running Ansible, the command Ansible. The next item that you can see on here is the group that we want to run this command against. I'm choosing to run this on the Jumpbox, so just this node here, 34.227.194.94. -m is the module that I want to run. I'll talk about modules in more detail in a little bit, so just trust me on this for right now. We'll circle back to this. There's a ping module, and it does what you think it would do. Is it's going to run like you would type ping, and it would run that command. And then -I need to tell it what's the inventory file. Now, I'm expecting this to fail, and we'll talk about the reason why it fails in a moment. But you can see the reason. It says it's unreachable. It can't connect, and it's trying to connect using my last name, R. Cravens, and it's trying to connect with kind of a public key or any keys that it finds, in my .ssh directory. That's not the right credentials. So I want this to work. I need to provide just a little bit more information here. What I need to tell it is -u for Ubuntu user. I need to tell it where the key file is that I used to create that EC2 instance. And that happens to be on my desktop in a Laravel_demo directory. And then it's called Laravel_demo.pem. And if you create EC2 instances, you know that that's the PEM file that Amazon creates for you. And so you just save that on your local disk. And the rest of the command is the same. So I'll run this on the Jumpbox group. I want to use the ping module, and that's the inventory. So I'm going to run this. And now it completed the command. So you can see it reached out to this host, which was the host that I specified, the Jumpbox. And you can see that it went out and it pinged. It was successfully pinged. It's starting to tell me some facts about that managed node. So on that managed node, it found Python 3.10, which is great. And then the ping response is Pong. Now I can run that again, but instead of running it maybe on the Jumpbox. So what if I run that command on all? So everything in the group, let's run it. And you see the response here. That first EC2 instance, the Jumpbox, using those credentials, Ubuntu and that key file, it was able to ping, it was able to connect. Then the other three, which are the swarm manager and the swarm workers, it failed to connect. This is the wrong key. It's the correct, these are EC2 instances, so the Ubuntu user is correct, but that's the wrong key. That's not the key I used to create these EC2 instances. So how do we fix this problem? So we want to introduce, instead of the inventory.ini file, this doesn't allow us to build in the right information. So we're going to go to this inventory.yaml file. So the .yml file, now I can specify these groups. I can build this inventory, and you can see that here. Here's the Jumpbox. Here's the host. It's called box number 1. Here's the Ansible host. That's the IP address. You can see the swarm manager, 1 IP address. The swarm workers, I have 2 of them, 2 IP addresses, and then I can build these children. But you can also see in here, there's these vars. So using these vars, I'm able to specify what the Ansible user is. It's Ubuntu. Where's the private key for these particular boxes? So all these boxes, here's where the private key is. Same thing for the manager. So the manager node, it's using Ubuntu, but it's a different key. These workers, they all use the same key as the manager. So these are all there. Now you could, instead of having this at this level, you could push this in 1 level or 2 levels, and so these vars are now part of these workers here, this worker. So this is associated with this worker. I'm not going to do that in that case because this is really associated with all of these hosts. So now let's go ahead and rerun some of these commands. So here's our inventory command, but instead of using the ini file, we're using the YAML file. And you can see similar results, right? A little bit different because I have some additional information. I have a name now for this box. I have the host or address, and it tells me what the data is for the key. So all of that additional content is available in the JSON file here. So now if I were to go back and look at this command that failed the last time. So here was, I'm trying to run this ping module over all the groups. So a couple of changes here. I guess switch out to my YAML file. Another change is I do not have to supply this key or this user. So I can shorten up this command quite a bit, which is convenient here. And we're going to shorten this a little bit more in a second here because we're going to be able to get rid of this -i inventory. I'll talk about that in a little bit. But first thing is I'm just going to run this. So I scroll back to the top here. I ran the ping, and you can see I'm getting Pong back from box number 1, which is the Jumpbox. Manager 1, which is the swarm manager. I'm getting Pong back. Worker 2, Pong back. And worker 1, Pong back. It went over all the nodes in my group, which was called all, and it did a ping command for them all. So one thing I do want to do is I want to shorten this up a little bit more. This -i inventory, or specifying that inventory, that's very common. And so Ansible makes this easy. You can drop in an ansible.cfg, a config file for Ansible, and in here you can specify which inventory file that you want it to use. There's a couple of other configuration variables in here. I'm not going to cover those for now, but this is the one right here that's important, is I specified the inventory file as this inventory.yaml. Now, when I run this, without that -i inventory, I can shorten up my command a little bit more and it'll still function. So I get the same results as I just had, but I didn't specify an inventory file at all. All right, so at this point, you can imagine the power we have to run some ad hoc commands on all of these servers. So before we take a look at a few examples, let's just look at the help for the Ansible command. What I want to see is there's a lot of options here, but there is a -a, which allows me to pass arguments into the module. And we talked about these modules. We specify them with a -m. So let's look at the -m. That's the module name. And it looks like the default module is something called command. So we're going to look at running some commands, some shell commands on these managed nodes. So let's take a look at this command. We're running Ansible. So we're going to target all the managed hosts. We got the -a, which specifies this is the argument that's going to get passed into the module. We don't have a -m, so we're using the default module of the command module. So this turns out to be the command that's going to get executed on the remote machine. lsb_release -aac is a command that tells you what the Ubuntu instance is. So we're going to run that, and you can see the responses. I get worker 1. Here's the response of Ubuntu 22.04. Box 1 is Ubuntu 22.04, manager 1 is Ubuntu 22.04, and worker 2 is Ubuntu 22.04. Notice the response that we're getting. First came worker 1, then box 1, then manager 1. We don't get to choose what order these things come in. So under the hood, it's going to try to do these in parallel. And whichever one gets the response first on that network, depending on the latency and who did it first, that's the order that they come back in. So if we run this again, it's not guaranteed to be the same order. Let's do that one more time just to show that. The last time we got worker 1, then box 1, and then manager 1, then worker 2. This time we got box 1, manager 1, worker 1, worker 2. So a different order. So with this module here, this is the command module, we can feed any arguments that we want. So I don't have to do this lsb_release. I could run the date command and I would get the date on all those servers. Now the challenge that we have, if you use the module command, things aren't always idempotent. You can even see that here. So these responses, it's always changed. So I kind of want to shy away from just running commands like that directly. I wouldn't want to run, for example, apt install nginx. That will function, but that's not going to be idempotent. I would want to use an apt module for that. So we're going to take a look at a few modules next. So here's an example. We're going to run the Ansible command just on the jump box. We're going to target the jump box. The module that we're going to use is a built-in module called setup. And what setup does, it goes and inspects the managed host and it returns a lot of content, a lot of data about that host. So we're going to run that. And you can see again, the content's in JSON format. And as I scroll back through, there's a lot here. I'm not going to stop to visit all these kind of name value pairs and all this data, but you can get the idea. So we're user data, there's host keys, there's information about IP addresses, how many processors, there's host names or node names, there's information about the different mounts that you can see, IP addresses, free memory, just a ton of data. That's important because at some point you're going to want to harvest or use some of this information in your tasks or in your playbooks. Here's another command. So again, Ansible, or target the jump box, a different module this time. We're using the apt module. We just talked about how we want to be idempotent. Apt is idempotent in that if nginx is already installed and it's already present, then this will come back as nothing changed. And that's what we want to see. Targeting the jump box, this apt module is going to run an apt install if it has to get nginx and make sure it's there or present and installed. But if it doesn't have to, it won't do anything. So let's go ahead and execute this command. And then what we see is box 1 was targeted, came back success. You can see right here, changed as false because on this box, nginx was already installed. And being idempotent is so important for Ansible. I want to be able to run these scripts and I want to know if something actually got changed on the box and what got changed. One last example of a different service is kind of related to nginx like we just had looked at. Instead of the apt module, now we're going to use the service module. And the argument that we're going to feed to it is we're going to feed in the nginx and we want to know if it started, if that service is actually started and running, and if it's enabled so that on restarts, it will start up automatically. And by the way, while we're here on this, these modules, like this is the service module, if you ever have questions about what arguments it takes, it's a pretty easy search. Ansible, I put in the name of the module and then put module at the end. It's usually the top one, and you're going to get the documentation for that module. And in the documentation, you're going to find out a lot of information about the module. Here's a list of all the parameters or arguments that it takes. More importantly, at the bottom, there's usually an example that will do exactly what you want. You can also see a couple of different formats here. The values or the attributes are entered on the next line. In the example that we're about to run, it's all kind of on the single line. Normally, If I'm running command line, it's usually here like this, but if I'm running it in a playbook later on, you'll see I prefer that other method where the attributes are on their own line. So let's run this. Again, we get our JSON response. We're going to scroll to the top of this, a little bit of information in here. It says success. Did it change something? No. So nothing was changed. Is it enabled? It's already enabled. Is this state? It's already started. Here is a status of this Nginx service. So you can see all the information about the Nginx service. If we needed to kind of harvest that information to do something later, we could do that. So there is some value in being able to run ad hoc commands on the command line like this. Especially if, for example, you run into issues where, I don't know, you got to look and see, is everyone's date set correctly? So maybe sometimes there's issues with the dates and the dates are off. So you can run these ad hoc commands, get the information you need to help troubleshoot. However, there's a lot more power in running playbooks. And so we're going to get to playbooks next. Okay, so let's introduce the concept of playbooks. Again, we talked about these earlier. So playbooks are like a high level part of the hierarchy. A playbook can contain many plays and a play can contain many tasks. So I have 3 different directories here, playbook 1, 2, and 3. They'll become increasingly more complex. So we're going to look at playbook number 1. In this directory, there are 3 playbooks that we're going to look at, and there's a couple of variable files, and we'll take a look at those when time comes. So the first time is we're going to look at this ad hoc examples. We just ran a bunch of ad hoc commands. Now, normally, I would want to kind of orchestrate those commands, like an apt command to install Nginx. There's a service command to make sure the Nginx service is running. And there's other commands too, to like copy an Nginx comp file from a directory that's here, local, to each of the modules. So all of that is done by combining these different tasks. Here's an example of a playbook containing one play. So my first play right here, it's going to be run on these hosts, so the jump box. So if I wanted to specify other hosts, I could run it on all. If I wanted to specify a list, I could say jump box and swarm manager. I could do all of that. So this host variable allows a lot of power, and it kind of allows you to target these tasks to certain hosts. So for right now, I'm just going to go back to just the jump box here. And then the third variable that we'll see in this playbook is the list of tasks. So here's task 1, which is to ping the server. Task number 2 is to ensure Nginx is started and enabled. Task 3 is to kind of gather the information about that host. And we'll talk about this one more specifically in a little bit, because this is automatically part of a lot of different playbooks. And there's a command that I can use called get facts, and we'll see this on other playbooks in the future. But for now, let's go ahead and run this. So I'm going to copy and paste the command in. So Ansible-playbook is the command that we're running. And now we specify the playbook. So it's playbook 1, which is the directory, and then that's the name of the playbook that we're going to run. We're going to go ahead and let this one run, and then we'll talk about the results in just a second. And so we'll scroll back through these things. So you can see at the very top, it says play. My first play, giving you an indication that of this name here. So that's the first play, that thing that's running. It's doing something called gathering facts, and by default, the plays do this. This gathering facts is done on all the different boxes that are in this host, and that way we can use those facts later on. We're going to cover this in next play, so we'll talk about that in more detail. And then you can see task number 1 runs, which is the ping task. And that's has a name, ping the server, and you can see it kind of written out here. For clarity, I can see exactly what's running. I can come back through my code, figure out, oh, that was the module that failed if something failed. None of these failed. I'm using the Ansible, the built-in module. So that's the format here, is you name it and then you tell it which module to run. And then you provide any parameters or any information to that module. So this module doesn't need any parameters, or we didn't use any in this case. The next task is here, ensure Nginx is started. And that corresponds to this one right here. And we're running the service task. It's the same service task that we ran by the command line. So we did that earlier with the service. And here's the parameters. So I kind of like, instead of feeding them in like the command line where I use all the equals, we're just using YAML here. So the name is Nginx. I want to make sure it's started and enabled. So that was something that we did. And then the next task was inspect and gather facts. So that's here. That's the one that we wrote. We're running this built-in module called setup. No parameters fed to this module, but we are registering something called facts. So all of the data that's collected by the setup is stored in this variable called facts. And then I have one more task, which is a debug task that prints facts out. So you can see that here. That's the debug task. It's printing the facts out, and here's the Ansible facts. That's the same thing that we ran before to get all that information, IP addresses and everything else. So now we can start to see the power of Ansible, right? I can build these tasks. And again, I'm not really building much here. These are kind of contrived examples, but I'm using tasks. I'm building them up in kind of pieces, and I'm trying to create some play or some bigger component here. So that's example number one. Let's take a look at example number two. At the very top, this is the name of the play. So debugging groups and fact data. We're running this on all our hosts. I'm telling it to gather facts. Before this play is run, Ansible will go out to all the different nodes and gather all the information it can find on all these nodes. And it's pretty smart. It does this, I think, once. It doesn't do it on every play. So if it has this cached already, then it'll just use the cached results. And then here's the list of tasks. So these tasks, most of them are commented out. We'll comment them as we go. There's a debug and it just says message hello. And I want to run this first of all, O2 inspection. And running this by itself kind of allows you to see under the hood what's going on a little bit more. So remember, we were running this against all our hosts. So here is a single task, and you can see that single debug task right here. But you see it output 4 times. It did it once for box 1, it did it once for manager 1, it did it once for worker 1, it did it for worker 2. Up here, you can see gathered facts for box 1, manager 1, worker 2, worker 1. The order, like you can't control the order, just like I can't control the order here, it will be different all the time. So this simple task is run the same number of times as I have in my all group, which is 4 in my case. So now we're going to comment this bit of code out and we're going to run the next one. Actually, we'll run them both here just to have them sandwich each other a little bit. Same playbook, run it again. I have this one here that nothing will change, and you can see that right there. It's going to output hello 4 times. Here, it only outputted goodbye once. And the reason it did is because I put this additional command or attribute on this YAML saying, hey, run this once. And this is important. Sometimes you want your task to only run once. There are cases where you want to have that fine control over it. So I'm going to comment out these top 2, and we're just going to look at a variable called groups. There's a number of variables, and we'll talk about the next one here. It's called host vars that Ansible provides for you. So you can always go to these variables and get data. So let's take a look what groups has. So I'm going to run that same playbook again. And you can see it only run it once, so I just get the information once. And the variable groups, JSON, that's my output all the time. But you can see that inventory data. So groups is really synonymous to inventory. When I ran inventory before, I got the same data, but here I can see all of these different groups. So one difference between groups and inventory is all the data that the inventory contains, like the IP addresses and all the different variables. That's not present. It's really just the names of the different machines. So under all, you see box 1, manager 1, worker 1, worker 2. That corresponds to these names. So under jump box, the name was box 1. Under swarm manager, it's manager 1. Under swarm workers, I had 2, worker 1 and worker 2. So those names are what are shown here. You can do things now like index it into here, and you can index this 2 different ways. So one way is I can say index it in, I just want to say the jump box. So print the variable groups.jumpbox. Let's see what we get when we run this. And you can see now the jump box is printed out. So I'm printing just box 1. That's the result. You can also index into these things like this, I believe. All right, so I get the same result there. That's groups. The next variable I want to take a look at is host vars. Host vars, because I'm gathering facts at the very top here, and gather facts, it sticks all those facts into a variable called host vars. And so we're going to take a look at that. And you can see a lot went by. This is a lot of information. So much so that it's hard just to scroll through. But every single remote node, it's gathering all that information and it's telling you everything about IP addresses, the size of the RAM, how much disk space, everything is on there. But you can use this host vars data and figure out information about your system. It takes a little digging. So usually what I did is I copy and paste this. I put this into a tool that will format JSON a little bit easier for me, and I can close nodes and hide them. But if you look at this, I commented a little bit more. So I'm going to get the IP addresses for each of the boxes. So I'm using host vars, which is the top level, and then I'm indexing into box 1. Indexing into worker 1 and worker 2. I'm indexing using the other method that I talked about here. And then for each of those, I'm getting this variable, Ansible default IP4, and then the address. And we're going to print that out. So let's go ahead and take a look and see what this does. So this is the output here. So box 1, which is right here, box 1, colon, and then all of this stuff is using a templating language called Jinja. And I'll pull the web page over. I left this link in the GitHub repository. You can go and look at it. But Jinja uses that mustache type of syntax, and then it will fill the variables in for you. So you can see it here. So here's our double mustache, and then inside is the variable, and it's finding out what all of these are, and it's printing them out. So the value of that for box 1 is 10.1.12.235. The value of that for manager 1 is 10.10.1.14. And so these are the IP addresses, and I think they're the private IP addresses for these different nodes. But that's an example of using host vars to dig into and harvest information about our nodes. Sometimes instead of doing this, these are kind of like hard-coded, right? So I had to hard-code box 1, which is here. Hard-code manager 1, hard-code worker 1, hard-code worker 2. I can use a loop construct that Ansible has. And so I can use this with items construct. And what I'm going to do is I'm going to use our groups variable. I'm going to feed in the .all. So if you remember what groups was, it had a list of all the different node names. So it'll give me box 1, manager 1. And so it's going to feed that into a variable called items, or a variable called item, I should say. And so you can see here is the item. So this is a very simple task. All we're doing is we're looping over all of the values in the groups.all value, and then we're going to print whatever is under item. So let's just see what it gives us. Okay, so you can see it's looped 4 times, all under box 1. So it's just running it once, box 1, but what you can see is the item is called box 1. The second time through it's called manager 1. Third time through it's called worker 1, and then it's called worker number 2. Given that, I can write something a little more complex. And this is that templating language here. So everything is pretty much the same except for this debug statement here. I'm looping over the groups called all. Here I'm printing item, which is what I did up above. And then here I'm digging into host vars to find out what the IP address is. This is almost equivalent to this kind of manual one up here where I printed these out manually. So let's go ahead and run this and see what this gives us. And so you can see here, box 1 is 10.1.12, manager 1 is 10.10.1, manager or worker 1 and worker 2. We'll look at something a little bit more complex here. So almost the same thing. We have a with items. Here is our groups.all. I'm moving over every remote node that's in the all group. Up here, I'm setting a fact. So I'm creating a new variable. And this fact is going to be available to me in this playbook. So there's this private underscore IP underscore lookup table. I always use LUT for a lookup table. So I can do operations in Jinja, like, if I have an instance already, I'll use it. Otherwise, or I'm going to go with this default, which is an empty dictionary. So if I have a dictionary, if it's already defined, I'm just going to use it. Otherwise, I'm going to create an empty dictionary. And then I have this combine statement here on the side. So this combine takes 2 values. So first of all, there is the item, which is going to be box 1, manager 1, worker 2. And then the second one is the other part of the dictionary, which is going to be this IP address. So essentially, I'm building a dictionary that will allow me to look up IP addresses given the host name. So if I run this, see what that looks like. So here is the output. So you can see here's where it created that private IP lookup table. I ran it once, and now here's my debug statement. I'm printing that out. So that's what this is right here. I'm printing this lookup table out, and then you can see this dictionary. Box 1, here's the IP address. Manager 1, here's the IP address. So now I have this lookup table. I can use this in other code that I might use to, for example, get the IP address of, say, box 1. So that's an example right here of how you would get box 1. So if I rerun this, and I just uncommented this last task here, now you can see here, this is the IP address of box number 1. So I created this lookup table. I can now use that in other bits of code. And then given kind of a host name, box 1, manager 1, worker 1, I can find its IP address. All right, and then there's one more playbook in this directory called variables. And so here we're going to introduce this concept of variables. And variables are important because they allow you to create a little bit more dynamic scripts or dynamic configurations here. And so we'll go through this play. So this play name is called variables, variable files, and secrets. Hosts, we're just going to run this locally. So we're not running this on any of our remote nodes, just local hosts here. These are just concepts, but you could run this on the different nodes and have these variables available to you when you're running on remote nodes. In this case, there's no need to do that. We're just running this host just locally here. The connection, we're setting connection to local, so it's not going to go out and gather any facts either. So the next thing you'll see on line 6 is we define some local variables, local to this play. In this play, I have these variables, var1, var2, var3, those are the names, and then the values are on the right-hand side. And then I also have this var files, and I'll come back to this in a little bit, but var files is going to import variables from files that are external. So there's a settings.yaml file, which is here. and there's a secrets.yaml file which is there. And so if I look at settings, we'll see what settings is. Settings has, it's a YAML file, it has a couple of different variables. So there's an app name, ABC application. There's an author, which has Jinja format, right? So I'm grabbing two variables, author first name, author last name, which are actually defined below. So I think how this templating engine works is it reads everything into memory, and then it kind of figures out what needs to be templated, and it takes a second pass. So it already kind of knows the values, and then it goes back and it fills them back in. And we'll see that in a little bit. But here, author is something that's derived from these other variables. And then I have an API token in this settings.yaml file. And just to be clear, I mean, this is not the secure way to do your API tokens. I'm putting this in here as an example of how not to do it. We also have a secrets file, which we'll talk about in a little bit, but this secret message here, again, this is not encrypted. This is not how you do this, but we're going to introduce something called the Ansible Vault in a second to help us make this a little bit better, a little bit more secure. So those are the two variable files, and this is the playbook file. I've introduced local variables, and I've also loaded in or imported in the two variable files. So let's take a look at my tasks. My tasks are pretty simple. They're just all debug messages. Debugging from our local vars, debugging from our settings file, and debugging from our secret message. We're gonna go ahead and run this. All right, so that's the variables, and we're gonna run this, and we'll get what we expected. So if we go to the very top, the very first task was to print out var1. This is var1, and you can see that here, this is var1. Prints out var2, 1, 2, 3, 4, 5, 6. Prints out var3. var3 again was a derived or built up variable, and we're deriving it from var1 and var2 using Jinja. So you can see that here, and that's the result. So that template engine has done its job. It's taken those variables and it's stuck it into our template and built out what we wanted here. And then the next three are from the settings file. So you can see the app name, the author, and the API token. And again, this author was built up from other variables, and so you can see Jinja again, it did its templating job, and it kind of pushes together for you, and you can see that it built out the name. API token, again, not the secure way to do it, and then finally we got the secret message, which again, not the secure way to do this. Okay, so how do we make this secure? I have this secrets file with the secret message, and I don't want people to know what my secret is. All right, so let's go grab a command here. I'll paste this in. This is directly from the GitHub page. Ansible-vault encrypt, and then I'm giving it the file that I want to encrypt. And I'm going to enter on this. It's going to ask me for a password. I'm just going to put secret in there, and it's going to make me confirm it. And then as I confirm, watch what it does to the content here. You see the contents have been updated. It says Ansible Vault, and it's using ES256. So all of that string that I had before that was visible, it's no longer visible. So now if I rerun the playbook using the command that I had previously, this is going to error out. It's going to say, hey, whoa, I detected an encrypted file and I couldn't get to it. Now, if I want to decrypt this, I can decrypt this, but I want to run this playbook without decrypting it. There is an option on playbook where I can ask it for this vault password. What I'm going to do is I'm going to enter here. It's going to, hey, what's the password? I'm going to type in secret again. So after I supply it the password, obviously it ran, it was able to access the password here, but this file is encrypted. So if you have to store your secrets and they have to be checked into maybe a Git repo, at least use Ansible Vault to encrypt them. There are still probably better ways to do that using some other kind of secret managers, but this is not a bad solution if this is what you have. And finally, if I want to decrypt this file, I can run the decrypt command over that file. It will ask me for the password, and then it'll say decryption is successful, and then I get my message back. So now I'm back to where I was before. Okay, so that's it for all of playbook 1. We're going to look at playbook number 2 in a moment. Let's go ahead and look and see what's in playbook number 2. A little bit more complex, but not too much of a stretch. So we're going to go through all the files and then we'll run this thing. So we're going to start with the playbook itself. So the playbook itself has one play, and you can see it's called deploy my PHP application. And as you can imagine by kind of that description, that's a little bit more complex. So you can see down here that there are 4 lines including other task files, and we've organized those in this tasks directory. So there's a task directory, and inside here, there's going to be 4 files. We'll look at these 4 files in a second. But let's cover the other things. So hosts, we're going to run this just on our jump box. That's the only one I want to be configured in this way. Become. So a lot of times when we do installations on remote machines and we're in our SSH shell, we have to sudo to run a command. And so what this means is become sudo for all of these tasks that you're about to run. There's one variable file here called settings. We're going to take a look at settings right now. There's only 2 variables in here. One is the HTTP port and the other is a from name. And we'll see where those are used in just a moment. So let's take a look at install packages. This task was right here, and you can see it uses the apt module, the apt module, and we're going to install some of these prerequisites. So here you can see another loop context. So we had with items before, but now we're using a loop. So here we're providing a number of variables, which is one in this case. Here's the one where we're providing 2 of them. So in this first one, we're going to loop over this. Is going to be aptitude. So that's the name for apt module to install. We're going to update the cache. State is the latest one, and we're going to force apt get to yes. And again, if you have questions on any of these values, you can take a look at the apt. If you look up Ansible apt module, you'll find all of these different settings here for this apt module. And the second task is we're going to install the whole limp stack. So Nginx and PHP in our case. We're not going to do MySQL. MySQL is a little more complex, and we're just going to skip it for this thing. But I leave that to you to do on your own. So that's our first one. Our second one is configure Nginx, and that's here. Look at that next. So configure Nginx only has 3 tasks. So it sets the Nginx comp file, and you can see here the source of this is our files directory here. And then there is an nginx.conf.j2. J2 is the Jinja extension. So you see my IDE, it's recognized it as J2. It's a Jinja extension. So if we take a look at that nginx.conf file, we are going to see some mustaches in there. So that's the variable. HTTP port, it's going to fill that in dynamically for us. From our settings files, it's going to be port 80 eventually. And that's what is going to go into our nginx.conf. We're using a template module. It's going to take that source, and Jinja is going to do its templating job. It's going to take the variables and kind of fold them into us. And then finally, it's going to save this in this destination on the server, which is just our Jumpbox server. Force means that even if this file exists, we're going to upload it again. And we're going to force this because, if I make any changes here on this side, if I change, for example, this NinjaX comp file, I want those to take effect. If I didn't write force and I were to change the port, then it would not take effect. So you can see that this first task, now I have an app.conf file. The second one, we're going to create a symlink. So we're using a file module to create a symlink between that file that we just created and the Nginx sites enabled. So Nginx has two folders. Usually there's a sites available, and you can have a bunch of conf files and sites available, but only the ones that have symlinks in the sites enable actually will be served up. So here we're creating that symlink. And then finally, Nginx usually ships with a default conf file. And so what we're going to do is if there's a symlink in the enabled, we're just going to delete that. So that is configure Nginx. The next one is deploy PHP. So we look at deploy PHP. Only has 1 task. So first of all, let's take a look at our template file. So our index.php is pretty simple. It has a hello Ansible from. Here's my variable, the from name. If I go to my settings, that's Bob right now. And so that's what this template is doing. And then I'm just using PHP info to tell me about the system. So it's going to use PHP info to dump all the information about PHP on there. It's putting this file into var/www/html/index.php. And if I look at my Nginx comp file, that is the root of where my web application lives. It's looking for an index.php file. If it finds any PHP type files, which is a map here, and then it's going to pass those through the CGI proxy, which is our PHP FPM proxy that's running. The final task is reload. So I look at reload. We're using a couple of services here, and we're just making sure that that PHP FPM service is reloaded, and also the Nginx service is reloaded. So we're going to run this playbook and let it do its thing. Okay, it's completed. And if we scroll to the very top, after I ran this thing, it's gathering facts, and then it includes this task. Here's the first one, install packages. You can see it ran over the couple of tasks that were there for install prerequisites and install the limp packages. Then it included this configure Nginx tasks, and there was 3 of them in there. Sets Nginx conf file, enables a new site, removes the default conf, and then it included deploy the PHP. For that, it pushed over the change, so it now made the change to the PHP info page. Then it did the reload, and here you can see it made those changes. Okay, so now that that's successful and it's done, let's go ahead and look at that page. We're just going to refresh this. I already did this once before, but you can see now here it's running. So it says hello Ansible from Bob, and then here's all the PHP info stuff that we saw below. Let's make a quick change to this. Let's say we're going to change our variable name. So instead of Bob, let's make it from Sarah, and let's redeploy this. We'll let it get through its deployment. We'll take a look at our page in just a moment. So that deployment has completed. If we go back to our page, this was the page before. And if I refresh this, now it says Sarah. So we can see with a very simple playbook that's well organized and structured, I can maintain and manage this deployment to a production. Now, is this production ready? This is probably not production ready. There's considerations like firewalls and things like that you have to consider. Maybe having my Ubuntu automatically do its security updates. Those are all considerations that we can add, but those can just be tasks. So you can add different tasks for all those. Okay, so let's move on to our final playbook here, playbook number 3. And when you look at playbook number 3, it's a lot simpler than playbook number 2. There's only 2 files in here. There's a playbook and the settings file. Let's take a look at this code. So the playbook first, we'll look at this. So we'll look at the header first. Provisioning EC2 instances in AWS. Wow, that's powerful. Ansible has a collection that's available to it that allows it to interact with Amazon AWS. So I can spin up EC2 instances, I can create a VPC, I can create a subnet, I can create security groups, I can create IAM roles, and I can do all of this programmatically using Ansible tasks. Just let that soak in. That's pretty powerful. So you can write infrastructure as code to kind of manage all of your servers and all your remote assets. So this particular task, we're just running localhost and we'll see that in a second because there's not really any servers that exist yet. So we're just running this locally, connections local. It does have a var file of settings. We'll look at the settings and we'll go through these as we look at our tasks that use them. So there's only 3 tasks really. There's a debug task at the top that prints out the Amazon key pair that we're using. There's a debug task at the bottom that prints out this EC2 variable that we're registering as part of this middle task. The middle task is really where everything happens. This is really where we're provisioning this new EC2 instance. Let's take a look at this. I always find these things pretty incredible. Let's take a look over here and do an Ansible module search here. Usually the top ones, and you can see all the different parameters that it takes. The parameters, there's a lot of information here about the parameters. I'm not going to spend too much time. I'm just going to scroll pretty fast past this, and we're going to get to these examples. You can usually find what you want in these examples, and you can see some of the power. So here, for example, I can shut down all of the EC2 tasks that are in a running state. Now, would I want to run this script against my whole Amazon AWS infrastructure? Probably not. And here it says use with extreme caution on that one. But I can do other things. Like I can create new instances. I can add EBS volumes to them. I can add in VPCs and all this other information. I can pick my different type. Instead of a T2 micro, I can want T2 XL. So there's a lot of power in here. That's just one module. What I open up here is now a page with the collection of AWS. So this namespace amazon.aus, there's a collection, and this collection has a lot of information. So for example, there's a dynamic inventory plugin. I'm not going to cover that in this one, but you can imagine, before we were managing kind of inventory state in a file. So I manually typed those IP addresses in, I manually grouped them. But now if we're going to start to automate our infrastructure and build these dynamic EC2 instances, I also need to dynamically create my inventory list. And so that's what this plugin allows you to do. You can dynamically create your inventory list. You can put tags on all your EC2 instances, and those can become your inventory groups. So this is a swarm manager. This is a swarm group or swarm worker. And then look at these modules. So there's auto scaling, there's backup, CloudTrail. We just start looking at EC2. We're looking at this EC2 instance module. It's one of the modules, but there's all these other modules that allow you to take snapshots, add security groups, create VPCs, create internet gateways, and add them all together and connect all this together. So you can really build your architecture programmatically. This infrastructure as a code concept can be real. So you can write your Ansible playbooks to manage and build all of your deployments. So if we take a look at the specific one that we're doing, EC2 instance, key name. So these are Jinja variables again. They're coming from the settings. The key name that we're using is Laravel_demo. This key already exists. If it didn't exist, if I wanted to, there's a module from Amazon AWS in that namespace that I can create a new key pair, and I can save that PEM file. I can save it locally so I can reuse it later on when I want to connect. Image ID, Amazon AMI. So that Amazon AMI is right here. So that is, I believe, an Ubuntu 2204 image. Instance type is that variable, T2 micro. Subnet. Now here I have a variable with a subnet ID. If you didn't have an existing subnet, in this case I do, and I'm just going to put this EC2 instance in that subnet. But if I didn't have an existing subnet, I can use the Amazon collection and create a VPC and create a subnet in that VPC and add an EC2 instance to that subnet. And then finally down here at the very bottom, you can see these Ansible tags. The tag name, capital M, has a special meaning when you put that tag in there. That actually becomes the instance name. Over here, I have these tags here. I'm going to assign it a public IP address. So we're going to wait for it to be there. I'm only going to spin up one, but you can imagine you can have 100,000, whatever you want it. But let's just be a little careful here. We're just going to spin up one, and we're going to register that new variable. I want to run this command. This is Ansible playbook, playbook 3, playbook. So we're going to run that playbook. Before I run it though, let's take a look at my EC2 over here. So I refresh this, reload this page. I've got my one jump box, and I've got my two swarm workers, and I got my manager worker. That's all I have running in this. So that's all I have running right now for EC2 instances. So let's go ahead and spin one up. So we're going to run this playbook, and we're going to let it do its work. Now it will return eventually, but it is going to wait until it gets to a certain point in the process. We're waiting for it to have spun up that new EC2 instance. It doesn't mean that that instance is accessible yet, so I can't necessarily SSH in, but you know how it kind of goes through that provisioning process where it's still maybe spinning up. But here's the results for it. And before we go too far with these results, I just want to go back to here, and I'm going to refresh. I already see that it's running. So it's already in some running state. It's still initializing though. Okay, so I've got this new instance. It's running, but initializing. Over here, this new variable EC2 has all of the JSON. It's a JSON file. So I have all this content. There's a lot of information in here. So for example, here's my public IP address. Here's the private IP address. So if you wanted to kind of harvest some information from these EC2 instances as you spin them up and store them someplace, you can do that because you have access to the information. Okay, so we're still waiting for it to spin all the way up, but what I want to do is I want to rerun the command. Because remember, we talked about idempotent, that this should be idempotent, meaning if I run this command again, I've asked for an instance with this key pair, it's in this subnet ID, it has this name was in here. If I ask for this again, what should it do? If it's idempotent, it's not going to give me another one. It already made one for me. It's going to just keep that one. What we're going to do is we're going to run this command again, and let's see what it does here. And it returns pretty quick. I still have my EC2 data. Okay, but if I look here, at the very top it says changed, false. Let's see if I scroll back up to where the other one said changed was true. So the first time I ran it, it made a change. So it created that EC2 instance. And I have an instance ID now associated with this. The second time I ran it, I still get the data. So here's my EC2 data, but changed is false. It didn't have to do anything different because I already have that instance. And that's the concept of idempotent, right? So I can run this as many times as I want, and that system won't change. I know it's already there, and it's in the state that I want it to be in. And so finally, you can see that this Ansible is fully running. Everything is there for me. All right, so we've successfully used Amazon, the AWS collection, to spin up an EC2 instance. Now, there's a lot that we'd have to probably do with this instance before we could really use it. You know, as an example, there's no security groups attached to this. So if I look at the security on this, inbound, we can use 6379. Not sure why that's open, but there's nothing else open. No SSH, no HTTP, HTTPS. So if we really wanted to kind of dedicate this as maybe a web app or something, we would have to do some work and create some security groups. And then when we spin up that EC2 instance, we can attach those security groups to that instance. Or we could attach it to it after too. But so that's definitely one of the things that we'd have to do with this EC2 instance to make it usable, is I have to add the security roles that it needs. I also have to add things like any IAM roles that maybe it would need. All this provisioning, there's Ansible collections in the AWS collection that I can use to accomplish that. So I'll leave that to you, but that's a good direction that you could head, is once you have the EC2 instance spun up, start thinking about how you would add the roles you need and push code down to it. Once you have the roles added to it, then you could easily circle back and use playbook number 2, which was deploy the PHP application. So once you provision everything and you got the security roles and everything all set up, then we could push the PHP application to it. Right now, I would not be able to do this because Ansible cannot SSH into that box because we didn't open up that port. All right, so what's next? I mean, we went through 3 different kind of directories with a bunch of different playbooks in there. We started off easy. We ended up with being able to provision an EC2 instance in Amazon. So I go back up to the very top up here. There's some links here that you can dig into a little bit deeper. For example, the built-in modules. If I open up that built-in modules link, there are a ton of modules. Just scratch the surface. We used a few of these. So we use, for example, APT. APT is a package manager for Ubuntu or Debian system. There are other package managers available for other Linux varieties. There's also a generic, if you look for, I think just it's called package. So here, there's a generic OS package manager. Ansible is trying to allow you to write scripts that are generic. So if I want to spin up an Ubuntu instance, yes. I want to spin up a Red Hat instance, yes, because we're not going to lock ourselves into using APT, but we're going to use this more generic package manager called package. But the point is, like, where do you want to go next? Start looking, just scan this and see if there's any packages like, oh, all right, I do a lot of stuff with, mail. I want to look at the built-in mail packages. Another place that you should look is the Jinja templating. I went through some simple examples, a little bit more complex stuff you can find here to start to dig into the Jinja a little bit more. And then we also talked about the Amazon AWS collection. Now that collection is pretty vast, and we saw it by itself. But if you didn't notice, on the left-hand side, that collection is just one of the collections that's in Ansible. So here's collections for Amazon. Underneath of it is collections in the Ansible namespace, Arista. Down here's Azure. So if you do a lot of stuff with Azure, you want to build up your deployment in Azure. You can build it in Azure. As you look through, there's a lot of different collections for Google, Grafana, that you can see already here that exists. Kubernetes, these already exist in this kind of built-in namespace for Ansible. Ansible has an ecosystem here that you can see it's already kind of vibrant on its own, but one more place that you want to look is something called Ansible Galaxy. And what Galaxy is Galaxy is kind of a repository where people can upload Ansible code for you to use, roles or other collections. And so these are built by people like you and I, so you can come in and find other different collections. And then finally, there's so many people that have kind of done Ansible scripts already, probably in the area that you're looking for. That's pretty easy to, type in Ansible and say Docker Swarm, for example. You'll find a whole bunch of things here in Docker. Here's a Docker Swarm module that's in kind of the community. Not only am I finding this, Docker Swarm, here's a bunch of people that have wrote Ansible scripts on how to spin up Docker Swarm. And the challenge you will find is some of these things that are like 7 years old may or may not work anymore, but at least they point you in the right direction. Hopefully you found that interesting. I have another video coming out here on Ansible and spinning up Docker Swarm instances. That's going to be part of that Laravel starter kit. So you'll be able to type in kit provision and it'll provision up your whole infrastructure for you. Keep an eye out for that soon. If you like content like this, hit that like button and subscribe. We'll see you next time.